Good morning. Monday, April 27th, an odd day. Uh, I got questions on the same one. It was the most complicated one of the problems that I had given you on, I want to say Friday. And I have it up on the board, and I'm going to solve this one again and, solve it for you a couple of different ways so you can see a couple of different things in it. But it was the copper nitrate problem, which was the last one on the first page of problems that I gave you. Okay. I have it written up here. Now remember the general rule, right? That when we do this, right, compounds will sum to zero. It's the same sheet that I have because these are the kind of rules that you need to remember. And after I go over this problem, I'm going to take you on to the next leg of this concept where we start doing the actual oxidation and reduction, tracking the changes in the number. So it's crucial that we learn how to assign the numbers because then the whole rest of the topic you're kind of going to be lost, which is why I took my time and I was patient with this and, give you plenty of opportunity to ask questions and stuff. And I will release Castle Learning this afternoon. I'll probably have it up, uh, hopefully by 10 o'clock, 11 o'clock. I don't know what time you're going to look at this, but I'll give you like 2 or 3 days to do it. I'll probably, and it's only going to be like 5 or 6 questions. It's not going to be a lot, but just practice assigning numbers because this is what you need to do to solve any of these problems. Okay, so copper nitrate, the whole thing has to add up to zero. And if you remember from the problem from Friday, I probably told you that this was the answer, right? +2, +5, -2, those numbers add to zero. I know you look at it, you don't see that, but remember, you have 2 of these N's and 6 of these O's, so it will work out. And one of the questions that was given was like, why don't we just write, 2, 10, and -12? Because we're tracking the change for only one of those atoms. That's why. And at the end of this, when I start showing you the changes, you might see why a little bit better. But let's start looking at it this way and start involving other our rules, expanding it as I've showed you before. Copper, nitrate, nitrate. This 2 means 2 nitrates. And I'm going to break that down even further and you'll see it. But if I remember that the copper was +2, I figured out the copper +2 because the nitrates are -1. Now, this is not a number that you're going to use to start a problem, but it's what you're going to do to rationalize your answer of +5 and -2. This is the answer. Okay, that's the way it should be written. That's the answer. You can also expand it a little bit further, right? +2 +5 -2 -2 -2. This right here, I'm going to circle it and then take that circle away because I don't want it there. But this +5 -2 -2 -2, that's a -1. The nitrate is a -1. So when you have a polyatomic ion, use the charge of the polyatomic ion to figure out what the polyatomic ion is with, like the copper, and then use it to find the charge of what's inside the polyatomic ion. Okay, and then we do that twice. Take this away because it's not part of our problem. We do that twice, and then we get another +5 -2 -2 -2. And if you add up all these -2s and all the +5s and this +2, it works out to a total of +12 and -12, which is 0. No matter which way we solve this, we're still going to get that answer. Okay? -1 does not come up as a possible charge for oxygen here because the oxygen rule is stronger than both the nitrogen rule and copper rule. So oxygen would not be a -1. The only time oxygen is going to be -1 if it's with rules that are above it. So oxygen's always going to be -2 unless hydrogen, fluorine, group 1 and group 2 are there with nothing weaker. Okay? And then it would depend on how many of those group 1 or 2 elements are there. Like in H2O, oxygen is -2, but in H2O2, oxygen is -1. So it depends on what it's with. If oxygen is only with hydrogen, then oxygen will change. All right. So that's how that problem is solved. Uh, the rest of them are pretty straightforward. I'm going to show you the next step, which involves oxidation and reduction, tracking the changes. I'm going to give you some pages in the book and maybe some problems to do. Well, actually, with the quiz enough, it'll be enough. Maybe I'll give you problems tomorrow because that'll be too much. But at least let me introduce to you at this point in time the things that are changing, okay? In an equation. I'll give you a simple equation to start. I'll probably put a little pause in there so you can do some of the problem. Okay. Where's my marker? Here it is. If you remember when I was in class, I was always putting my marker down and forgetting where I put it. It's still happening even though I'm at home. Okay. And yes. Since I'm at home, I have hot coffee. Though I had that at work too. All right, so let me give you a possible problem. AG plus, actually, the AG would come out. It's got to be the other way around. Sorry. AG parentheses NO3. The parentheses is not necessary in this one. I put the parentheses in there so you can more clearly see that it is a polyatomic ion, make the problem a little bit more followable for you as a single replacement. Plus Ca yields CaNO3 2 plus Ag. Okay. What I'd like you to do is write that down. I'm going to say it again because I know my handwriting is not super good. But it's AgNO3 plus Ca yields Ca parentheses NO3 2 plus Ag. Write that problem down on a piece of paper. Assign the oxidation numbers. Okay. So once you have that written down, press pause, assign the numbers, and then unpause it. I'll have another sip of coffee while you're doing that. Okay. Hopefully at this point in time you've unpaused it. I'm going to start assigning the numbers. All right. I'm going to start with the Ca and the Ag because those are the easiest. Okay. That's my first little note on here. Elements will be 0. So these are zeros. Now, the NO3 works out to be the same charge that it was in the other problems. NO3 is a polyatomic ion. It's equal to -1. Since oxygen has a rule that would be stronger than nitrogen's, oxygen's -2, so nitrogen has to be a +5. So I just worked that one out again. It's the same thing. So I'm putting +5 and -2 in both of these places. Okay, and now I'm going to use the charge of this polyatomic ion as a whole to figure out the last thing in there. In this case, there's one NO3, which is -1 because of those charges. So Ag has to be +1. And since there's two NO3s, both of those NO3s are -1 each, the Ca has to be +2. Oh, but wait, I really didn't have to do that, did I? Why didn't I have to do it? I didn't have to do it because calcium is in group 2. It would have been +2 anyhow. And that's always +2. But I did it intentionally so I'll show you the way it worked. And now, this is what we do. We look for the things that change. The nitrogen and the oxygen in the nitrate polyatomic ions did not change. Nitrogen's +5 here, oxygen's -2 here. +5 here, -2 there. There's no change. What we want to do is track the change of the individual elements in the numbers that are in the equation. We want to track the changes in the oxidation numbers. One's going to go up, which is oxidation. The other goes down, which is reduction. So remember when we did like ABBA and BAB and all of that stuff for the acid-base equations? We're kind of going to do the same thing. We're going to write connectors, and it can be first and last, inners and outers the same way. In this one, it's the inners and outers. And look what we have. Ag is silver. Silver is going down. When the charge goes down, we call it reduction. The charge is being reduced. So it's red by 1. Reduced by 1. It's a reduction process. And the calcium is going from 0 to positive 2. When it goes up or increases, it's oxidation. So I'm going to say it's ox by 2. So we have 1 oxidation, 1 reduction. All redox reactions are going to have 1 oxidation, 1 reduction. If the oxidation numbers change from the reactant side to the product side, we have a redox reaction, okay? What I'm going to suggest that you do after your quiz, because this video is only like 10, right now I'm at a little over 11 minutes. I'm going to be cutting it out soon. Do your quiz, and then look at pages 181 and 182. I said 180. My eyes are bad. I am sorry. Book is right in front of me. 161 and 162 in your book. Just the reading portion, and you're going to see there's like questions, like 20 questions that go on between pages 162 and 163. I'll discuss and assign those tomorrow, but I'd like you to look at the reading on those pages so you can absorb it a little bit and think about it in terms of what I have here. There are also something in there that says, Leo says GER, all right? Loss of electrons is oxidation, gain of electrons is reduction. We'll use that to identify answers in some of the problems too. I'll talk more about that tomorrow, but for today, I want you to, get on that quiz. I'm going to open the quiz up today, like I said, by somewhere between 10 and 12 by the time I get everything done. I'll get that on, and then you'll take it. I'll probably give you a couple of days to do it because I know there's always a lot of other things going on and problems with internet on and off, and I get that. People have told me that, and I get it. Remember, don't take these quizzes or tests on Castle Learning unless your connection has been good for a while. You know what I mean? Because I know, like, even sometimes me in the morning, I have to go downstairs, turn off my router before my device will connect to it. And like, you guys use the internet more than me, so you probably understand a little bit more about it, how to keep your internet running too. So make sure you're doing that. All right. Castle Learning is going to go up in a little while, and I'll see you again tomorrow morning. Have a great day. Bye.